Okay, so this is going to be our last video concerning this example problem. And what we've done in the previous video is that we've went through now and we've taken a look and we've plugged in numbers into the matrices itself. And hopefully we kind of get a better picture of where these numbers are coming from. Another thing that I forgot to do in the past video is we have this A prime and A double prime, right? So we need to go through and we need to replace the numbers here just like we did over here. So A prime is the absorbance at 390, so that's 0.651, and A double prime is going to be 0.547. So we actually forgot to do that last time. 0.651 goes here and 0.547 goes there. Okay, now we can go ahead and solve both of these matrices, and the way that we do that to solve a matrices is that we take a look at the determinant up at the top and up at the bottom, or the matrix up at the top and up at the bottom, and we calculate what we call the determinant. And the way that we do that is that we cross multiply. So I'll take 0.651 and I'll multiply it by 0.279. And when you do that, 0.651 times 279, you'll get 181.629, and then you're going to cross multiply the other two. So 0.547, and you're going to multiply by 172, and you're going to get 94.084, and you subtract those two numbers. That's how we calculate the determinant. So up here at the top, it's 181.629 minus 94.084, and we're going to end up getting 87.545 as a number up on the top. You do the same thing down here below. You cross multiply 678 times 279, and you're going to get a pretty large number, 189,162 minus, and then you cross multiply these two. So this is 526 multiplied by 172, and you're going to get 90.9472. So you subtract those two numbers, 189,162 minus 9472, and you hit enter on your calculator, and you're going to get 98690. So from this point, I can just simply type in 87.545 divided by 98690 and hit enter, and my concentration here is 8.87 times 10 to the negative fourth, and that represents the concentration of titanium. So that's how I would solve the matrix algebraically. Alright, the same thing is going to happen here with vanadium. What I can do is I cross multiply, and we'll work through it step by step, and you can follow through me on your calculator if you need to. But you take 678 and then you multiply by 0.547, and you should get 370.866 minus, and then you do the same thing to the other two numbers. This is 526 multiplied by 0.651, and you'll get 342.426. So that goes into the matrix up at the top. Down here below, 678 multiplied by 279, that gives me 189,162. And then I subtract that from the other part of the determinant, 526 multiplied by 172, and that equals 9472. So if I start plugging these numbers into the calculator, 370.866 minus 342.426, that gives me 28.44. If I do 189,162 minus 9472, I get 98690. Notice this is the same denominator because this part of the matrix on both pieces are the same. So 28.44 divided by 98690, and I hit enter on the calculator, and I'll get 2.88 times 10 to the negative fourth, and these are in molarities. So for titanium, 8.87 times 10 to the negative fourth, and then for vanadium, this is 2.88 times 10 to the negative fourth. So that is how I solve the matrix problem on a sheet of paper using a calculator, which is my friend in this case. Now, if you have a TI-84 Plus, you can actually go into the matrix. If you look on your calculator, you will see an X to the negative 1 button. In blue, probably, up on the top, you will see the word matrix. Okay, so that means that you will hit second function x to the minus 1, and that takes you into the matrix screen on the calculator. Notice that there's things called names, math, and edit up at the top. You can actually use this button on your calculator, plug in the numbers to the matrix in your calculator, and have the calculator solve for the matrix for you to get 8.87 times 10 to the negative fourth and 2.88 times 10 to the negative fourth. So it can be done. I'm not going to tell you the step-by-step details on how to get it done, because I think it's good for you to kind of walk through this whole solving the matrix kind of problem to see where these numbers are actually coming from, instead of relying on a calculator to do the work for you. So it's better to know where the numbers are going and what kind of calculations are basically being included, just versus taking advantage of a little bit of technology to do everything for you automatically. So that is solving the UV-Vis matrix. This type of problem you might see on the exam. And the reason that I say that is because all of the information is given to you here. So I'm giving you the molar absorptivities of each one at their lambda maxes. I'm giving you the molar absorptivities of each one at the other components' lambda maxes, and I'm giving you the absorbances of the mixture at each lambda max. All of that information can be presented on a table in the actual exam, and I will go through and give you the matrix problem. I don't want you to memorize this setup. I'll give it to you. You just have to plug the numbers in like we did here and begin to solve for the concentrations. So this type of problem could show up on the written part of the exam. For the lab practical, there is a possibility that I could go through and give you a mixture and tell you to analyze the mixture, and then go home as part of your take-home assignment and solve for the unknown mixture this way. So there's a couple of options that I could do. That's just one of them, and I'm just kind of giving you a heads up on what you could see possibly when it concerns that take-home problem and the lab practical portion of the problem. So that ends this example. In the next couple of videos, we'll look at where maybe these molar absorptivities have came from, instead of just assuming that we know how to calculate them. We'll do an example where we actually have to calculate those molar absorptivities, kind of like how you have to do in the chrome manganese lab. So stay tuned.